Okay, so just back for one last time, just to finish off the last two questions of this exercise. Questions 18 and 19. Oh, question 18, an arrow is fired vertically into the air and takes 4.2 seconds to return. What was the initial speed of the arrow just after it left the bow? Alright, so this is our scenario here, that our arrow is going up and coming back down, and this whole trip took 4.2 seconds. So probably the easiest way to break up a problem like this is to chop it in half, and we know that the time it takes to go up is the time it takes to come down. So if we chop it in half, let's chop our time in half, leaves us with 2.1 seconds. Okay, so our initial velocity is our unknown. Our time now is known at 2.1 seconds. Our final velocity, so at the peak of its trajectory here, is, sorry, that should be U for initial velocity. Sorry, no one's perfect. V is 0 meters per second, and acceleration is 9.8 meters per second squared. Now, with these types of equations, we need to label directions as positive and negative. Just out of habit, I have up as positive and down as negative, and just be consistent. You don't want to confuse yourself on something like this. So that means my acceleration is acting in the downward direction, so this needs to have a negative in front of it. Okay, three knowns, one unknown. UTVA. UTVA. V equals U plus A T. V U A T. Sorry, I'm just starting to lose the plot here. So V is 0 meters per second. U is our unknown, plus acceleration, which is minus 9.8 times by time, and time is 2.1 seconds. 2.1 seconds. Okay, so 0 equals U plus 9.8 minus 9.8 times by 2.1 equals minus 20.58. Alright, we want U by itself. We need to add 20.58 on both sides, because this is a negative. So we would have 20.58, adding it to both sides cancels that out and gives us 20.58 on this side, equals U. Right, so U equals 20 point, let's round it up to 6, and what is it? Speed, meters per second. Alright, and it's positive, it's not a negative, so it's in that direction. Absolutely, if the arrow is going to end up there, it's got to be shot in that direction. So happy with that, 20.6 meters per second. And if you want to give a rough check of your answer, 20.6 meters per second, and we know that it took 2-ish seconds to get to the top, and the acceleration slowing it down at 9.8 meters per second every second. So if it's slowing down at 9.8 meters per second for 2, it should be around the 18, 19, 20. Alright, that looks pretty good. We haven't made any silly mistakes. Okay, the last one was quite involved, and that's why it's worth, can you see that? 5 marks. So there were 2 calculations to be made here. First of all, let's pull out our knowns. Willie is driving along the road at 70 kilometres an hour. Okay, so our initial speed is 70 kilometres an hour. When a dog runs out onto the road up ahead, he applies the brakes 0.5 of a second later, which is his reaction time. Whilst the brakes are applied, he decelerates at 8.4 meters per second squared until his car comes to rest. What distance did Willie's car move from the moment the dog ran onto the road? So there's 2 things we need to work out here. The distance he travelled before he started braking, and the distance he travelled whilst he was braking. So his initial speed of 70 k's an hour, let's first of all change that to meters per second, divided by 3.6, is 19.4 meters per second. Alright, so he was doing this speed for this long. So our first little distance to calculate is velocity equals change in distance over change in time. Velocity is 19.4. Delta x over delta t is half a second. 19.4 times by 0.5 equals 9.7 metres. Okay, so this is our first bit. So he travels 9.7 metres before he starts braking. How far does he travel while he's braking? So, again, his initial speed is the same, is 70 k's an hour, which we know is 19.4 metres per second. He decelerates at 8.4 metres per second squared. What else do we know? Until his car comes to rest, so his final velocity is 0 metres per second. There's our three knowns. And our unknown is the distance. How far did he travel whilst he was decelerating? How many metres? Okay. UAVX. That one with T in it. UAVT, no. UAVX. This will do us here. V squared equals U squared plus 2AX. V squared 0 squared equals U squared 19.4 squared plus 2 times by A, which is 8.4 times by X. Well, we don't know what X is. 0 squared is 0. 19.4 squared is 376.4 plus 2 times 8.4, 2 times 8.4 equals 16.8x. Alright, I want to try and get x by itself. Let's subtract 376 from both sides, 376.4 from both sides. That means this is gone. On the other side we have 16.8x. And then we need to divide 16.8. 16.8. I was wondering where this negative has come from, and what I should have done, because it's decelerating, this should be a negative number in here, which makes this a negative here, which makes this a negative here. So we've got negatives on both sides, so we can cancel that out. So we end up with 376.4 divided by 16.8, 376.4 divided by 16.8 equals, you can see that, sorry I'm running off the page here, equals 22.4 metres. Is that our final answer? No, it's not, because we need to add this. So 22.4 plus 9.7 equals 22.4 plus 9.7, 32.1 metres. That's the total distance he travelled whilst he was braking. Okay, so that's it. As soon as I've got this little gizmo working, I'm going to work on those solutions to the sheet I gave you today about Newton's